everyone. Welcome to EquaticMath. This is Pranjal and today we are going to start chapter 1 of class 9th, that is rational numbers. Before starting this chapter, let us first discuss about the topics we are going to cover in this chapter. In this chapter, first of all, we will cover our very first topic, that is rational number, means what are rational numbers. After that, we will learn how to find out any rational number between the given two rational numbers, means we are given with two rational numbers and we have to find another rational number between those given numbers. Then how can we insert the rational numbers between any two rational numbers? Next is decimal representation of rational numbers, means we are given with the rational numbers and we have to convert those rational numbers into the decimal forms. How can we convert those rational numbers in the decimal expansions? And the next one is conversion of decimal number into p by q form. It is just the opposite of third one, that is now we are given with the decimal number and we have to convert them into the p by q form. P by q form means the rational number. Next, we will discuss about irrational numbers and after that we will discuss how to plot the irrational numbers on the number line. Next is rationalization, and after that we will learn about the exponents of real numbers. Before learning about the exponents of real numbers, we will discuss about the real numbers, what are real numbers, and then after that we will discuss about the exponents of real numbers. Okay, so first of all, let's recall what we already know. Means let's start with the natural numbers. What are natural numbers? Natural numbers are the counting numbers. Counting numbers means the numbers which are used to count anything, and we know that whenever we have to count anything, we will start from 1, 2, 3 and we will move up to so on, and it will go up to infinite. Means we have infinite numbers, so the counting numbers are infinite, hence the natural numbers are 1, 2, 3 up to infinite. Next is whole numbers. Whole numbers are 0, 1, 2, 3 up to infinite. Means the natural numbers including 0 are the whole numbers. Whenever we add 0 with the natural numbers, then they become whole numbers. Okay. After that we have integers. Integers are the positive numbers, the negative numbers and 0. Means whenever we combine positive number, negative number and 0, then they are integers. They are known as integers. Now there are 4 types of integers. First one is positive integer. Positive integer means 1, 2, 3 up to infinite. Next, second one are negative integers. Negative integers means -1, -2, -3 up to minus infinite. Next is non-positive integers. See, the word itself is showing what does it mean. Non-positive. Non-positive means those numbers which are not positive. Not positive means negative numbers and 0. Negative numbers and 0 means 0, -1, -2, -3 up to minus infinite. These are the non-positive integers. Fourth one are non-negative integers. Non-negative integers means those integers, those numbers which are not negative. Not negative means positive and 0. Positive and 0. It means 0, 1, 2, 3 up to infinite. Now See, from the third and the fourth part of the integers, non-positive integers and non-negative integers, we can clearly see that both these types of integers include 0. Means, why are we including 0 in both types of numbers? We are including both in 0 in both the ones because we know that 0 is neither negative nor positive. That's why we are including 0 in non-positive integers as well as in non-negative integers. Okay. Now, next is, what are rational numbers? Means, now we are going to discuss our main topic by which our chapter is named as, that is rational numbers. What are rational numbers? Rational numbers are those numbers that can be written in the form P by Q. P by Q form, where P and Q both are integers. Both must be integers. Integers means they can be positive, negative or 0. And there is one more condition, that Q is not equal to 0. Means Q not equal to 0 means we can take P as positive, negative as well as 0, but in case of Q we can only take positive and negative numbers. We are not allowed to take Q as 0. Means we are not allowed to take denominator as 0. If we can write any number in the form of P by Q, where P and Q are integers and Q is not equal to 0, then that number is rational number. For example, if I say that we have a number 2 by 3, we can clearly see that it is in the form P by Q. Here P is 2 and Q is 3. And we can see that Q means 3 is not 0. Denominator is not 0. Means 2 by 3 is a rational number. Similarly, minus 3 upon 5. It is also in the form P by Q, where P and Q are integers and Q is not equal to 0. Means denominator is not 0. So it is also a rational number. Next, if I say that we have a number 2, then 2 is equals to 2 upon 1. We know this already. So if we can write 2 as 2 by 1, then it shows that it is of the form P by Q, where P and Q are integers and Q is not equal to 0. So 2 is also a rational number. Okay. Now see this picture. In this picture, see, we are starting with natural numbers. First of all, we have the natural numbers. After that, the numbers which are include 0 with natural numbers are the whole numbers. The whole numbers are included in integers. Means natural numbers, whole numbers both are included in integers. And when we have the numbers which includes integers are the rational numbers. Means this picture is showing that rational numbers have integers, whole numbers as well as natural numbers. Integers have whole numbers and natural numbers. Whole numbers have natural numbers in them. Now, after that, let us discuss this question. In this question, we have to state the true and false. Now, see the first one. First question is, every whole number is a natural number. Means, see, whole numbers are, we already learned that whole numbers are 0, 1, 2, up to infinite, right? And natural numbers are only 1, 2, up to infinite. Can we say that every whole number is a natural number? No, because we know that 0 is not included in the natural numbers. So it is false. Okay. Second one, every integer is a rational number. Integer includes positive numbers, negative numbers as well as 0. And we had already seen the picture. See this one. Integers are included in rational numbers. So we can say that every integer is a rational number. It is true, right? We can say this. That second part is true. Next, Third one, every rational number is an integer. Can we say this, that every rational number is an integer? No, because integer only includes the positive numbers, negative numbers and 0, but they are not of the form p by q. If I say that we have a number 2 by 3, then it is of the form p by q. It is rational number, but it is not an integer. So the third one is false. Next is fourth one, every natural number is a whole number. Natural numbers are 1, 2, 3 up to infinite, and these all are included in whole numbers. So we can say that every natural number is a whole number is true. Next, fifth one, every integer is a whole number. Integer means positive, negative and 0. But whole number contains only 0 and the positive numbers. So negative numbers are not included in whole numbers. So it is not correct. Every integer is not a whole number. So it is false. Now the last one, sixth part, every rational number is a whole number. Rational number includes the numbers of the form p by q, and whole numbers only contains 0, 1, 2 up to infinite numbers. If we again take an example as minus 4 by 5, then minus 4 by 5 is of the form p by q. It is negative also. Negative numbers are also not included in the whole numbers. So we can say that rational numbers are not, every rational number is not a whole number. So the statement says that every rational number is a whole number. It is not correct. It means it is false. Okay. Now, okay. So the next topic is how to represent rational numbers on number line. Now we have the rational numbers and we have to represent those rational numbers on number line. Now there are three cases, three types of rational numbers. First is when n is greater than d, means when numerator is greater than denominator. For example, 5 upon 3. Second case is when numerator and denominator both are equal, means 2 upon 2. Right? And next is when numerator is less than denominator. Numerator less than denominator means, for example, 2 upon 3. Now let us learn how can we represent these types of rational numbers on number line. If we talk about the first one, when numerator is greater than denominator, now we took the example 5 upon 3, just convert it into the mixed fraction. We know that it is an improper fraction and we can convert the improper fraction into mixed fraction. So when we convert it into mixed fraction, we will get 1, 2 upon 3. It means 1, 2 upon 3 means it is 1 plus 2 upon 3, means 1 plus the 2 upon 3 comes after 1 and before 2, means this lies between 1 and 2. Means when we have to represent it on the number line, then we have to take, it is 0, then we have 1 and then we have 2, suppose. Now this lies after 1, means we have to take after 1, and after 1 we have to take 3 parts. As the denominator is 3, it means we have to take 3 parts. Means now I am dividing it into 3 parts. First part, second part and third part. Now it is 2 by 3. Now it is 1 upon 3 first part. This is 2 upon 3 second part. After 1, now we have to represent 2 upon 3 after 1. It means we have this one, and hence this is 5 upon 3. Hence we represented the rational number 5 upon 3 on the number line. Clear? Now the second type is numerator and denominator are equal. Now if numerator is equal to denominator, as we took the example 2 upon 2, it is 1. We can easily represent 1 on number line. we always know that this is number line. Now it is 0, it is 1, it is 2, this is 1, and hence we can also say that it is 2 upon 2. If we have suppose minus 3 upon minus 3, numerator and denominator are equal. Now minus 3 upon minus 3 is also equals to 1. So now in this case, this is minus 3 upon minus 3. Okay. Now the third case is when numerator is less than denominator. If numerator is less than denominator, it means it lies between 0 and 1 on the number line, because we don't have the whole part before this fraction as we had in this 5 upon 3 type number. Here we had 1 as the whole number, but in this question, in this part, we don't have anything, we have nothing as the whole part. So 2 upon 3 is the only rational number, only fractional part we have, and we have to represent it on the number line. Now as the denominator is 3, it means again we have to divide this number line from 0 to 1 into 3 parts. Now this is the first part, this is the second part, and this is the third part. Now after 0, it is the first part out of the third part, so it is 1 upon 3. This is second part out of the third part, 3 parts, so it is 2 upon 3. And we have to represent 2 by 3 only, so this is 2 upon 3 on number line. Okay, this is how we can represent the rational numbers on the number lines. Hence, now we had already shown all types of rational numbers on number line, whether it is when numerator is greater than denominator, or numerator and denominator both are equal, or numerator is less than denominator. Okay, now let's see the next topic. Our next topic is inserting rational numbers between any two rational numbers. Before learning how can we insert the rational numbers between two rational numbers, let us first discuss a thing, that equivalent rational numbers. What are equivalent rational numbers? These are the fractions that have the same value but are written in different forms are the equivalent fractions. Those fractions which have same value but are written in different forms are the equivalent fractions. For example, 1 by 2, 2 by 4, 4 by 8, 3 by 6, 6 by 12. If you see carefully, these all are equivalent fractions. By normally seeing this, we can say that these are the rational numbers. These are different. They are we can see that these are different ones. They have different forms, but in actual they have the same value. As 1 by 2, it is the simplest form. Now see this, 2 by 4. If we simplify 2 by 4, then we will get it as 1 and it as 2, means I am dividing 2 by 4 by 2 by 2. When we divide 2 by 2, we get 1, and when we divide 4 by 2, we will get 2 only. So 2 by 4 is equals to 1 by 2. Means this and this both are same. It means 1 by 2 and 2 by 4 both are same, but they are written in different forms. So those fractions which have the same value but are written in different forms are the equivalent fractions. Hence we can say that 1 by 2 and 2 by 4 are equivalent fractions. Similar way, let us see this example, 6 upon 12. If I divide 6 upon 12 by 6 by 6, then also we will get 1 by 2. Means 6 by 12 is also an equivalent fraction of 1 by 2. Clear? Now we will learn how to insert the rational numbers between any two rational numbers. See, there is a question. Find a rational number between 2 and 3. We have to find single rational number between 2 and 3. See, there are two methods to find the rational numbers between any two given rational numbers, whenever you have to find only one rational number, then you can use average method. Average method is you just have to add the given rational numbers and divide it by 2. The answer, whatever you will get, is the rational number between those given rational numbers. For example, see this question. You have to find a rational number between 2 and 3. Here we have to find only one rational number between 2 and 3. So we will use the average method. Just we have to add the given numbers, means 2 plus 3, and divide it by 2. From here, 2 plus 3 is 5, and in denominator we have 2. It means 5 by 2 is the rational number between 2 and 3. Okay. Now let's see the second question. Find a rational number between minus 2 by 3 and 1 by 4. Here also we have to find only one rational number, so we can easily use the average method. And average method says that we just have to add both the given numbers, means minus 2 by 3 plus 1 by 4, and then divide it by 2. Now we know that in the numerator we have 2 by 3 plus 1 by 4. We have to take the LCM of the denominators of these numbers, means we have to take the LCM of 3 and 4. And we know that the LCM of 3 and 4 is 12. So it is 12. And now as the denominator is 12 here, so we have to convert this minus 2 and 1 according to the 12. Now we have to just divide 12 by 3. We will get 4, and multiply it by minus 2, we will get minus 8. Now as it is plus, the sign of plus is here, so we have to put the same sign. And now we have to do this. 12 divided by 4, we will get 3, and then we have to multiply 3 by 1, we will get 3 again. And the 2 is in denominator as it is. Now see, it is minus 8 plus 3, it is minus 5 upon 12, and in denominator 2 is already here. Now we can write it as minus 5 upon 12, and 2 is also in the denominator. So the answer is minus 5 upon 24. Clear? It means the rational number between minus 2 by 3 and 1 by 4 is minus 5 upon 24. This is the rational number between minus 2 by 3 and 1 by 4. Clear? Now it is equals to minus 5 upon 12 and divided by 2. 2 is already in the denominator. Now we can write it as minus 5 upon 12 multiplied by 2, and it is equals to minus 5 upon 24. Clear? Now see the next question. Now again same question but with different numbers. You have to find a rational number between minus 4 by 5 and 1 by 2. Again we can use the average method in this, as we have to find only one rational number. So to while using the average method, we just have to add both the numbers, means minus 4 by 5 plus 1 by 2, and we have to divide it by 2. Now the next step is we have to take the LCM of 5 and 2, which is 10. Now according to this LCM, we will change the numerators, and minus 4 will become minus 8, and plus 1 will become 5, and 2 is already in the denominator. Now we will solve this. Minus 8 plus 5 is minus 3 upon 10 as it is, and in the denominator we have 2 here. Now we can write it as minus 3 upon 10 and multiply it by 2, as the 10 and 2 both are the denominators. So it is equals to minus 3 upon 20. So minus 3 upon 20 is the rational number between minus 4 by 5 and 1 by 2. Clear? Now see the next question. If you see the next question, it says find three rational numbers between -2 and -3. Here we have to find three rational numbers. Now to find more than one rational number, we are not going to use the average method, we will use another method. Now see what we have to do to find more than one rational number. Just see how many rational numbers you have to find. Here we have to find three rational numbers. Just add 1 in it. When you add 1, you will get the answer as 4, right? Now see what we have to do with this 4. Now you have to find the rational numbers between -2 and -3. Just write -2 and -3 here. Now you have to write the equivalent fractions. Now how can we find the equivalent fraction, and how can we know this, that whatever we will find as the equivalent fraction, it will give the three rational numbers between -2 and -3. To get exactly the given number of rational numbers, we did this thing. If we have to find three rational numbers, then we just have to add 1 and we will get the answer as 4. Now using that 4, we will find there means -2 and -3's equivalent fractions. Now we will write -2 multiplied by 4 upon 4. When we multiply 4 by 4, see 4 by 4 means, if I write 4 by 4, then it is equals to 1 by 1. 1 by 1 means 1, and we know that we can multiply any number by 1, we will get the answer as the same number. So we can do this. Now here when we are doing that -2 multiply 4 by 4, we will get -8 by 4, right? Now similarly when we multiply -3 by 4 by 4, we will get -12 by 4. Now see, we have to find the three rational numbers now. Now here we can write -2 as -8 by 4 and -3 as -12 by 4, and we have to find the three rational numbers between -8 by 4 and -12 by 4 now. When we will write the rational numbers between -8 by 4 and -12 by 4. These are -9 by 4, -10 by 4 and -11 by 4. These are the three rational numbers between -2 and -3. And now let's see the next question. Yeah. Next one is, now you have to find 10 rational numbers between 5 by 8 and 7 by 8. Now I just told you that whatever the number is given to you, how many rational numbers you have to find, you just have to add 1 in it, and using that number you have to find the equivalent fractions of the given rational numbers. Now as we are given that we have to find 10 rational numbers, just add 1 in 10, you will get 11. Now using this 11, you have to find the equivalent fractions of this. Now we can write 5 by 8 as 5 by 8 multiply by 11 by 11, you will get 55 by 88, right? Next is 7 by 8. 7 by 8, we have to find the equivalent fraction of 7 by 8. So we will multiply 7 by 8 by 11 by 11, and we get the answer as 77 by 88, right? Now see, the rational numbers between 55 by 88 and 77 by 88 are 56 by 88, 57 by 88, 58 by 88, 59 by 88, 60 by 88, then 61 by 88, 62 by 88, 63 by 88, 64 by 88, 65 by 88. These are the 10 rational numbers between 5 by 8 and 7 by 8. Clear? Similar way, next question is you have to find 30 rational numbers between minus 3 by 6 and 2 by 6. This is your homework question. You have to do it by your own. Give it a try. If you find any problem in this, just write it in the comment box. I will let you know the answer. How can you find the solution of this question? Okay. So this was all for today. I hope you like this thing. If you like, then please subscribe the channel and press the bell icon and give more and more likes and comments. Thank you so much. Bye bye.